All right, I want to start 7.4 by making just kind of a random comment. So our Earth is round or spherical. If you want to try to take something that's curved and put it onto a flat piece of paper, it's going to cause distortions, which is why some maps, if you see like a flat map of the whole Earth, it's going to have some weird cutouts to it. If you're mapping a smaller section of the Earth, that can be done well, so you don't have to worry about that. You might see that coming up a little bit later on. All right, so scale. First thing I want to do is when you're talking about a scale in an object, so a scale, and this is a review from 7.2, is the scale is going to be the new divided by the original. Or in 7.1, we talked about that it's the map, I wouldn't write this in, but it's the distance on the map divided by the distance in real life. So I wouldn't do that second fraction. But that really we're looking at what is it on Earth, that's the original, and then they make the maps from what it is in the Earth. So scale is going to be new divided by original. Or you could take this ratio right here and you could also write it as new colon original. The book is going to use a different equation in number 1. You could use theirs if you want. You could go back to mine if you find it confusing. All right, so we're looking at this thing here. We're trying to figure out, well, what can we do scale-wise? We want to take a map thing here and make it into a poster, but sometimes the dimensions aren't quite exactly the same, so we're trying to figure out what's the biggest that we could take and blow this thing up and still have it fit on the poster. All right, so we're going to have to figure out both scales. So I'm going to take that thing there. I'm going to say scale is new divided by original. So scale, I'll maybe do an equals this sign. Scale equals the new divided by the original. And, well, we're going to take the map and put it onto a poster. So the poster has to be the new. And we could look at this as though it's maybe like width and height, and width and height. So we have the two smaller ones both being widths, the two bigger ones both being heights. Doesn't really matter which one's width and height, but we're going to have to go through and figure out what scale could we use for the width to blow it up, what scale could we use for the height to blow it up. Then if they're not the same, we need to figure out, well, which one do we keep? Which one do we do in both directions? All right, so I'll maybe do like for my width over here and for my height down here. All right, so new, that's going to be the poster. So width, my new one is going to be 51 centimeters. My original is a 12 centimeters. All right, once I have that, like we were doing before, we take that smaller one and I'm going to put a 1 down there. So that'll be like 1 centimeter. I suppose we don't need to have the units because they're the same, so I'll do a 1 and an X. We're trying to figure out a what to what ratio. So if I go through and cross multiply and divide that, I'm going to have my 12 times x, and I won't clutter it up too much. I'll do 12x equals, and then 1 times 51 going that way, so that just becomes a 51. Well, why not times 1? Divide both sides by 12, and x ends up being 4.25. So in other words, for this top one, I have a 4.25 over 1, or a 4.25 to 1 ratio. And because it's centimeters for both of them, I don't have to put units in. So 4.25 to 1. That it's going to get 4.25 times bigger. All right, now for the height, we do that same thing. My new is going to be 81 centimeters. My old is going to be 18 centimeters. And again, you could even, if you wanted to, drop the units here because they're the same. So I'll get rid of them there, perhaps. And now, all right, I want to make that then equal. I'm going to put a 1 down here in the smaller one. And I could go through and do my cross multiplying the same. I'm going to do this first because I like seeing x on the left side of my equation. 18x equals that times that. So 81 times 1. All right, if I want to solve for x, I could divide both sides by 18, and I'm going to get an x equals 4.5. So my 4.5 goes right there, which gives me a 4.5 to 1 ratio. So once we have that, we're saying we can make it 4.25 times bigger in the width. We can make it 4.5 times bigger in the height. So now which one do we keep? Well, if I can only make it 4.25 times bigger this way, if I try making it 4.5 times bigger in that direction, it's going to go off the page. So that's not going to work. So I'm going to end up keeping my smaller one. So when enlarging the object, keep the smaller difference. Keep the smaller difference. Or the smaller change, or basically keep that smaller number when it's in that front part. Because we found if we multiplied this by 4.5, it's going to be off the page. But this one here, if I can make it 4.5 times bigger, well, if I make it only 4.25 times bigger, it's not going to go off the page, it just won't quite go to the end of the page. So this example here then, when making things bigger, keep the smaller difference. Now, example 2 is going to look at what do you do when you're making something smaller. So I'll do the same thing. We're going to look at the width and the height, but drawing a model of a 12-foot by 66-foot plane on 8.5 by 11 paper, what's the largest scale you can use? All right, so I have my width and I have my height, and I suppose which one I count as which doesn't really matter, but if the plane is smaller in this direction, you're going to want to put it in the smaller direction on the piece of paper. If it's bigger in this direction, the bigger one there. So I'll have my width maybe be the smaller ones. So scale equals the new divided by the original. And we could do the same thing for the height. Scale equals new divided by the original. Instead of height, the bigger numbers. All right, so we'll go for the small one. So the new, the plane is 12 feet. We're going to put it on the paper. So the new would be the 8.5 inches. 8.5 inches over 12, the little apostrophe means feet, so I'll actually write out feet there. And we want to take this, and since the 8.5 is the smaller number, I'm going to put my 1 up there. So 1 inch is going to be x feet. So cross multiplying, I'm going to start with this one here, because then I get my x on the left-hand side. So that'll give me 8.5 times x. Equals, when you're cross multiplying, you go the other direction, so 12 times 1, which is really just a 12. I'm going to divide both sides then by 8.5 to get x by itself, and 12 divided by 8.5 will give me a 1.4. So x is 1.4. So this first scale then is going to be 1 inch to 1.4 feet. So every 1 inch on my paper is going to be 1.4 feet on the plane. All right, now we just kind of start over and do that exact same thing for my bigger two numbers. So my new is going to be my 11 inches on the piece of paper and my 66 feet on the plane. And we'll put the 1 in kind of that smaller direction again. So I have 1 inch over x feet. And we're going to cross multiply to solve that. So I start with that direction, and that gives me an 11x equals that times that. So 66 times 1. I would probably just write the 66 if I were doing this by myself. But all right, so then to solve for x was multiplied by 11, so I need to divide. So x then is going to be 6. So this second ratio is going to be 1 inch equals 6 feet. So I left it up there at the top of the screen. The first example, we were making something bigger. We kept the smaller difference between the two, which seems kind of backwards, but math sometimes seems a little bit backwards. Now we're shrinking something. We're taking a physical plane, and we're trying to make it fit on a piece of paper the same size as your notes. So for that, if we think about it, if I would have this 1.4 feet get shrunk down to 1 inch, okay, that's going to make it shrink a certain amount. This here is going to be a bigger amount of shrinking. My 1 inch, instead of just being 1.4 feet, is going to be 6 feet. So I need to shrink this one a lot more than the other one to make it fit on the page. So if I were to keep this ratio, it's not going to shrink it nearly as much as this. So then my 66-foot plane is going to hang way off the paper. So when you're making an object smaller then, you have to keep the larger difference. So if you think back, example 1, when making something bigger, keep the smaller. When making something smaller, it's going to be kind of that opposite seeming thing again. When shrinking an object, keep the larger difference. Because when we shrink it, this one is going to shrink both of them enough. This top one wouldn't shrink it enough to have it fit on the page. It would be too big. So when shrinking an object, keep the larger difference. So that's the section. Essentially, it's really just kind of 2 problems inside one. You get your 2 answers, and then you decide which answer to keep. And for deciding which answer, you need to pay attention to these 2 lines here. When you're making something bigger, keep the one that's the smaller change. When you are making something smaller, then you have to keep the bigger change. That's it. Let me know if you have questions.